molecular geometry. Let's go. Under this video, we want to make this thing so easy for you. Do you see this side, this table? I just took my time writing it down. Immediately you understand this table is over. The course is over. You are done. Now, under molecular geometry, I'm going to use what we call the AXE method to solve it. Now, you are to commit this to memory, but I will explain soon, and in under some minutes, the course will start making sense. And now we have, like I said, I'm going to use what we call the AXE method. Let me call this one M, and let me call this one A, N. Now, I'm going to explain what those terminologies means. A, please bring out your data. A means the central atom. The X is an atom directly attached to the central atom. An atom directly attached to the central atom. While the M is the number of atoms directly attached to the central atom. So this is the central atom. This is the number of atoms directly attached to the central atom. Of course, this is the M is the number of atoms directly attached to the central atom. While the X itself, the S itself is an atom directly attached to the central atom. Now, E is the lone pair of electron around the central atom. While the N is the number of lone pair electron on the central atom. Let me give you an example. Immediately. Let's say we have ammonia. And ammonia, you want to draw the Lewis structure. This video is not meant for drawing Lewis structure. That has already been solved. Now, if you want the Lewis structure of ammonia, this is N. And of course, you have nitrogen. This is hydrogen. This is hydrogen. And of course, we have a lone pair here. Now, A is the central atom. The central atom is the A. X is the number of atoms. The number of atoms directly attached to the central atom. Are you seeing it? Now, why this E is the lone pairs, while N is the number of lone pairs directly attached to the central atom. So if I put lone pair here, that is not your business. This is your business. The lone pair directly attached to the central atom. Now, if I ask you what is the shape of ammonia, and you draw the Lewis structure, the next thing is, this is your A, which is the N. Then you have your X, right? Then how many atoms are directly attached to the central atom is just what? 3. And then your E is the lone pairs. Is it not? Is it not? Good. So how many lone pairs do you have? You have only 1. So this is AX3E. And if you know that this is AX3E, you can just come here. That's why I say you have to commit this to memory. You can just come here and search which one is AX3E, and then you will know the structures. So by the end of this video, things will start making sense to you in a way it does not make sense to you before. So of course, AX3 is AX3E. So AX3E, of course, this is it here, and this is the trigonal pyramidal, and of course the bond angle is 109.5, and the hybridization is sp3. That's all. Can you see how easy this is? This is so easy. So once you commit this to memory, you can do your Lewis structure. You know what your AXE means. That is it. Life is easier. Now let me give you one more example. Immediately. Now let's say you have the shape of SO2. Let's say you have the shape of SO2. So SO2, of course, this is S is central atom, right? So you have O here. So you have double bond. draw the Lewis structure. So this is it. Now this is Lewis structure of SO2, right? Now I want you to determine the molecular geometry and the bond angle. Determine the molecular geometry of SO2, the bond angle, and the hybridization. So once you draw the Lewis structure, the next thing is you apply this formula. This is your A. Your X, which is what? The number of atoms directly attached to X. So the number is what? 2. And then we talk about the lone pairs directly attached to the central atom. So the lone pairs is just 1. And so this is the name. You are not concerned with the lone pairs here. This is not the central atom. You are concerned with the lone pair directly attached to the atom. And so this is AX2E. And so all you need to come here is to come here. AX2E is bent. And then the bond angle is 120 degrees and it's sp2 hybridized. This is so easy. So once you start knowing how to draw this, life becomes easier for you immediately, automatically. Now, let's continue, please. What if you have water, and let's say you have water, and remember you can also get some shapes. It's in the textbooks, in the school textbook, for you to also compare more. Once you just understand it, life is easier. What if you have water? So this is water, and the Lewis structure of water. You have hydrogen here, you have hydrogen here, and then you have 2 lone pairs. And so this is X2, E2. So all you need to do is just come. Water has also a bent shape, and you know the bond angle is here at the board. The bond angle is 109.5. So it's just so easy. It's just so easy. So remember, this my table is just some that I highlighted. You know, I don't have space to write everything. It's just for you to understand what it means, and you can just cram some of it. You can also source more of this table and how it actually relates to what we are doing. Now, we still have a question at the board. What if you have methane? Now, so what is the structure, the molecular geometry of methane? Now, you can see methane. This is, you have 4 carbon here, right? And so we have AX4. We don't have any lone pair, so no E. And so AX4, you come to this table. AX4 is tetrahedra. The bond angle is 109.5, and is sp3 hybridized. So easy. It's just so easy. So let me give you one for you to do. So please, what you have to do right now is pause the video. What if I ask you, what is the molecular geometry of SO2? CO2. What's the molecular geometry of CO2? What is the bond angle, and what is the hybridization? So CO2 is actually, because the carbon must be satisfied, so you have 2 dots here. This is the Lewis structure, and so this is X. How many atoms? 2. Do you have lone pair at the central distance? No. So of course CO2 is linear, so this is it, AX2, and the shape is what? Linear. The bond angle is 180 degrees, and it is sp hybridized. So this is so easy. Once you can just draw the Lewis structure, there's no any compound that they will bring for you that you cannot actually answer. Now, what if you have this BH3? Because boron is the central atom here. So you have something like this, hydrogen, and hydrogen. Please just pause the video and just solve it. And so you have X, right? We have 3 atoms surrounding the center. Do you have any lone pair? No. And so you just come here. This is trigonal planar, and the angle is 120 degree, and it's sp2 hybridized. So it's just so easy. It's just so easy. Now there's something that I still wrote on the board. I'm not forgetting it. I want to actually solve this like Lewis structure. Now look at it. They said determine the molecular geometry of NO3 minus. Now remember that S is equals to V minus A, and then your V is what? This is 8 plus 8 times 3, right? And this will give you 32 electrons. And then your A, the number of valence electron available, this is 5, nitrogen is 5, plus oxygen is 6 times 3 plus 1. Because of minus, you add plus, that will give you 24 electrons. So your S is V minus A. So your V is 32 minus 24, that will give you 8 electrons. Remember, in drawing Lewis structure, they say pick 4. Of course, the skeleton of that is, this is, the nitrogen is, and draw it like this. So now remember, they say pick 4 pairs of electron. Now I only put, this is 3 pairs, so it should be something like this. So the next thing is we have to balance. This is, and then this is 3, of course. And remember, I said in Lewis, at the end of the day, the total number of valence electron must be equal to 24, right? So here we have 8, 10, 12, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24. And so that means this structure is legit. So please, I'm just trying to waste time to refresh your memory on that legit structure. Now, we want to know the shape. So the shape of this molecule is actually, you have AX3. We don't have lone pair. So AX3, that is trigonal planar. And the bond angle is 120 degrees, and it's sp2 hybridized. It's sp2 hybridized. Now, there is something I also want to talk about. Now, a little bit of classwork under this. What if you have, and of course, please, you know, sometimes when I'm in a haste, I forget some certain things, like this VSEPR is an exam question. What it means is valence shell electron pair repulsion. That is an examination question. Please know the full meaning of what it means. Know the full meaning. Now, what is the structure of xenon tetrafluoride? You have xenon here. You have 2 lone pairs. You have fluoride here. Fluorine. Of course, we have 6, 6, 6, 3, 3 dots of electrons. So what's the shape here? Of course, you have your A, you have your S. How many atoms surrounds it? 4. You have your E. How many lone pairs do you have? 2. So that is just it. So you can just keep on practicing, and sooner or later you'll be very, very perfect in this. Now, from the board, there is a summary of all I've been saying. Whenever you have 2 atom molecule, like let's say nitrogen, the shape is always linear. Once they are just 2, like I'll ask you, what is the shape of chlorine? It's always linear. They're just 2 atom molecule. Now, whenever you have 3 atom molecule, and look at this. This my boss square here is lone pair on central atom. So whenever you have a 3 atom molecule, and if there is no lone pair, that's why I said no. It's just something to help you remember. if there is no lone pair on the three central atoms, the shape must be linear. Example is CO2. If you write the Lewis structure of CO2, it doesn't have a lone pair on the central atom, so the shape is linear. Now, for SO2 that we just saw, we had a lone pair on central atom. This was it. We saw something like this. So we had a lone pair on central atom. The shape is always what? Bent. Now, for 4 atom molecules, look at 3 atoms. Look at 1, 2, 3. This is 1, 2, 3. Now, 4 atom molecules, if there is a lone pair on central atom, if it's yes, the shape is always trigonal pyramidal. And this is 4 atom. When you draw this ammonia, that was the first thing I drew here. I had something like this. Hydrogen, hydrogen, hydrogen. You can see there is a lone pair on the central atom. So, of course, this is trigonal pyramidal. Now, if there is no lone pair, which is no on central atom, what you get is trigonal planar. An example of it is this. Now, what about 5 atoms molecule, like methane? Of course, it has a tetrahedral shape. So these are just something to make you or to aid you in understanding what we are doing, so that you not forget about it. So that is all for this course. Please remember that the table are just some selected few. So endeavor to make sure you add more on those tables. Thank you very much.